This is a differential equation of third order, and we need to find out the order of the matrices of the system which is described by a differential equation of third order. So here, by seeing the order of the equation, we can say that the number of state variables are 3 and the number of inputs 1 and output is also 1. The standard state model is x dot equal to ax plus bu. This is known as state equation. So the order of the matrix A, this matrix is known as state matrix, and it is order is 3 by 3 as the number of variables are 3. And x dot and x is a state vector and this is differential state vector. So the dimension of this is 3 cross 1. Similarly, x also 3 cross 1. Whereas the B matrix, this is known as input matrix, and the dimension of this is 3 cross 1 and input is 1 cross 1. So x dot, x and u are the vectors and A and B are the matrices. A is a state matrix and B is the input matrix. Now the output equation y is equal to cx plus du. This is known as output equation, where y is the output. So the dimension of this y vector is 1 cross 1 and C is known as output matrix. This dimension is 1 cross 3. X is a state vector, it is 3 cross 1, and D is the transmission matrix, it is 1 cross 1, and U is the input vector, it is also 1 cross 1. So when differential equation is given, first we need to choose the number of state variables and from then write the state equations and give the order of the matrices. When differential equation is given, how to obtain the state model? The equation is given by y triple dot plus 5y double dot plus 3y dot plus 10y, this is equal to 5u. So this is again differential equation of third order, and how to obtain the state model which consists of state equation as well as output equation. So let us consider y, the output, as one of the state variables x1. Call this as equation 1. Then y dot is nothing but differential of output, then it is equal to x1 dot. Consider this as another state variable, call this as equation number 2. Then y double dot is x2 dot, then this is another state variable x3, and y 3 dots, this is equal to x3 dot. Consider this as fourth equation. Now the number of state variables here are x1, x2 and x3. They are known as state variables, and x1 dot, x2 dot, x3 dot are differential state variables. Now substitute all these 4 equations in the main differential equation that is given. Now the equation y3 dots is given by x3 dot, state variable x3 dot, then plus 5y double dot So this is equal to x2 dot or x3, 5x3 plus 3 into x2, then plus 10 into x1, this is equal to 5u. Equation is described in the form of state variables now. The x3 dot can be written by 5u minus 10x1 minus 3x2 minus 5x3. Now we need to represent this in the form of state model. One is x3 dot and the other one is x1 dot and x2 dot. Standard form is given by x1 dot, x2 dot and x3 dot. This is known as differential state vector. This is equal to the first matrix. It is of 3 cross 3 because the order of the equation is 3. So we should have x1 dot equal to x2. So x1 dot is here. So when you have a 3 cross 3 matrix, then you have a state vector. This is x1, x2 and x3. So x1 dot, you can see here x1 dot is equal to x2. That means I must have here 0, 1, 0. So x1 dot is equal to x2. That way x2 dot is given by x3. So 0, 0, 1, the second row of the state matrix, and the third row is given by these three parameters: minus 10, minus 3, minus 5. So you have got the third equation, x3 dot is equal to, these three parameters have come in the state matrix. Now 5u is left. If you see all the three equations, x1 dot, x2 dot and x3 dot, plus you have an input matrix. This is given by 0, 0, 5, 0, 0, 5 multiplied by the input vector u. So this model is known as state model or state equation. This equation is known as state equation. Now we need to have an output. So output is y. So output equation y is equal to x1, you can see. So how to represent this? This as y output vector. This is equal to 1, 0, 0 into x1, x2, x3. So this is the representation of output equation when differential equation is given. Order of the differential equation is now 4, and you need to get again state model. So the procedure is the output variable y is to be chosen as x1, and y dot, derivative of y is x1 dot, that is equal to x2. Then y double dot is x2 dot, this is equal to x3, another state variable, and y 3 dots is x3 dot. So this is another variable because the order of the system is 4. So you have 4 state variables. Now the last one, you have 4 dots on y. This is x3 double dot or x4 dot. So the next step is the insertion or substitution of all these variables into the main equation. So it starts from x4 dot plus 2x4 minus 4x3 plus 6x1 is equal to 10u. The equation is represented in the form of state variables. Now as the order is 4, you get a matrix as a fourth order one. So there are differential state vector is given by x1 dot, x2 dot, x3 dot and x4 dot. This dimension is 4 cross 1. Now the state matrix will have the dimension of 4 cross 4. So this is 4 cross 4 multiplied by the state variables, state vector, again it is 4 cross 1. So using these set of 3 equations, we can form the first 3 rows because x1 dot is equal to x2. So the second component in the first row must be 1, the other components are 0. For x2 dot is equal to x3, so the third component is 1 and the rest of the components are 0. For x3 dot equal to x4, so the third row, all the elements are zeros, the last element is 1. Now very important is the last row of the state matrix. For that you need to see this equation x dot x4 dot equal to 10u minus these terms will go other side. So you can write now the x1 coefficient is 6 here, so it goes that side, it is minus 6. There is no x2 component in the equation, so 0, and this goes that side, so 4 is the x3 coefficient and minus 2 is the last component. So forming the state matrix using these equations is important to get the state model. Now the other part of that you have plus input matrix. It is only 10u is there, 10 is the coefficient. So the first 3 components are 0 and this is 10 multiplied by u. Now the output equation y is equal to x1. So how to represent this? So y as a state vector, this is equal to, you have output matrix, only first component and the other components are zeros, and you have x1, x2, x3, x4. So this is known as output matrix. So whatever may be the order of the differential equation, we need to assume first the given y terms in the form of state variables and form state matrix and then output equation. How to obtain the state model when the system is described by its transfer function? Transfer function is a ratio of Laplace transform of output to the input, and it has numerator term as well as denominator term in the form of s. So we know that when you have an inductor, the voltage across the inductor is given by L di by dt is a function, voltage across the inductor, and when you apply Laplace transform to this, VL of S is equal to L, and the di by dt is represented as S times I of S. So d by dt is replaced by S, and in this case when you see here, like differentiation, di by dt is nothing but I dot. So I dot is nothing but S into I. In a similar way, when you see here, there is an S here. So for this 3, you consider as 3x1, one of the state variables, and when you see S, this S is given by x1 dot. So this is equal to another state variable x2. Now when you see S square is nothing but double dot. So x2 dot, can consider x2 dot as S square, and this S is x1 dot and 6 as x1. So we are trying to get the given transfer function in the form of state equation. So we can write now the equation for output y is equal to 2x2 plus 3x1, and the denominator part is u equal to x2 dot, s square is replaced by x2 dot plus 5 x1 dot. This x1 dot is nothing but x2 plus 6 x1. This equation we can write now as x2 dot is equal to u minus 5x2 minus 6x1. So we need to represent now these equations in the form of state model. So the state model is again the differential state vector is represented by x1 dot and x2 dot. This is equal to, as x1 dot is equal to x2, so the first row will be 0 and 1, 0 and 1, and this will be the state vector x1 and x2. So x1 dot is equal to x2, and the second row is from this equation x2 dot. So x1 coefficient is minus 6 and x2 coefficient is minus 5. So you can see now x2 dot equal to minus 6x1 minus 5x2, but there is u also here, and so plus the input matrix 0 into 1 u. So this equation is represented in the form of state model x2 dot equal to minus 6x1 minus 5x2 plus 1 into u. This is the equation. Now the output equation is from this y is equal to 3 and 2 components, and x1 x2. So the state model, it consists of state equation as well as output equation for the given transfer function. So the system is now described by a transfer function again, and by seeing the denominator term you can see that it is s power 4. So there will be a state matrix of A 4 by 4 because the order of the system is 4. So the state matrix, how to form the state matrix for the given transfer function? So the size of this state matrix is 4 cross 4. A we call it as, the size is 4 cross 4, and the first 3 rows you can actually fill like 0 1 0 0 0 0 1 0 0 0 0 and 1. So it's like a differential state vector and state vector relation. With that, first 3 columns can be filled, and the last column is by seeing the denominator. If you start from the coefficient 9, assume that this is for x1, so with opposite sign you should write with minus 9. Then there is no s coefficient here. After 9, this is s power 0, then there is no s power 1 coefficient, so you simply put 0, and the s square coefficient with opposite sign minus 6, and s cube coefficient also 3 with minus 3. So the last row is from the denominator with opposite sign. The coefficients must be written starting from the constant and all other terms. So that is the way you should fill the last row of the state matrix. Now for the output matrix C, of the output equation C, by seeing the numerator, again you can see that the numerator you have 6 then there is no s term here, but s square and s cube has got coefficients. So no sign change here in the output equation. Starting from 6 s power 0, then there is no s power 1, put 0, and 4, and then 2. So this is 1 cross 4. The dimension of C matrix is 6, 0, 4, 2. It is 1 cross 4. And there is an input matrix also. Input matrix that is given by B, and whose components are 0, 0, 0, and the last is 10. The coefficient in the numerator, constant, can be taken as 10 in the B matrix. So this is the way you can actually form the state matrix by seeing the denominator with the coefficients of opposite sign, and for output matrix, numerator coefficients with same sign. The state model can be obtained using this. Obtain the state model again for the given transfer function, which has 3 poles and no numerator zeros in this system. Now when the system is given of this form, let us represent this equation in the form of partial fractions, and you can get the values of a, b, c as half by s plus 1 plus minus 1 by s plus 2 for b, and the c is again half by s plus 3. So this is the first step after giving the equation in the form of poles. Apply partial fractions and get the coefficients a, b, and c. Now this is the transfer function y of s by u of s. Now you write this equation for output. Take u of s this side, half u of s by s plus 1 plus minus 1 into u of s by s plus 2 plus half into u of s by s plus 3, and you can consider this as one variable x1 plus x2 plus x3. They are the state variables. Order is 3. 3 state variables x1 and x2 and x3. The 3 terms can be represented in the output equation. Now where x1 here is assumed, this is equal to half u of s by s plus 1. Similarly, x2 is the second state variable, second term here, minus 1 into u of s by s plus 2, and the third variable x3 is half u of s by s plus 3. Now you can rewrite this first term as x1s or sx1 plus x1 is equal to half u, the first term. This you can actually see s times x1. The meaning of this is x1 dot. The derivative of x1 is represented by sx1 Laplace when you apply. So this is x1 dot plus x1 is equal to half u. Similarly, the second term sx2 plus 2x2 is equal to minus 1 into u. So sx2 means again it is x2 dot plus 2x2 is equal to minus u. sx2 is replaced by x2 dot, derivative of x2. Similarly, the third term s into x3 plus 3x3 is equal to half u. So this is again x3 dot derivative of x3 plus 3x3 is equal to half u. So three equations are being written. Now we need to get the state model for this. So the state equation and output equation combinedly we can call it as a state model. So state equation it has got differential state vectors, three variables x1 dot, x2 dot, x3 dot. Now you need to form the state matrix here. State matrix here, you can see that if I want to get x1 dot, this is equal to half u minus x1. When I take this x1 to the other side, x1 dot is equal to half u minus x1. Similarly, the other components also will come that side. So we can write the coefficients for x1, x2 and x3 and form the state matrix here. This is minus 1, 0, 0, then 0, minus 2, 0 and 0, 0, minus 3 you get. So the dimension of the state matrix is 3 cross 3 because the order of the system is 3. So it is a 3 cross 3 matrix. Now the state vector x1, x2 and x3 plus, now you have the output input matrix and input vector. So this is given by half minus 1 half into u. So using these three equations 1, 2 and 3, you are able to get the state equation of the state model. So now the output equation y is equal to 1, 1, 1 and x1, x2, x3. Generally we consider x1 and x2 and x3 are the state variables. So the output equation is given by y equal to 1x1 plus 1x2 plus 1x3. So this is the way we should get the state model for the given system which is described by a transfer function.